The metric system is universally used within the sciences. However, some students really struggle with understanding metric units and scale. In this short tutorial, we'll discuss liters as the base unit of volume measurement and, using everyday objects as examples, try to give you an idea of the size and scale of various measurements based on liters. Let's quickly review the metric staircase that we discussed in previous lessons. Remember that as you move up the staircase, volume measurements increase in multiples of 10. And as you move down the staircase, volume measurements decrease in multiples of 10. Let's begin with the base metric unit of volume, the liter. To get an idea of scale, consider a bottle of water. A medium-sized bottle of water bought from the supermarket holds about 1 liter of fluid. In the lab, scientists typically work with volume measurements that are smaller than liters. So let's take a look at these smaller measurements. Deciliters are 10 times smaller than liters. A deciliter is equal to 1/10 of a liter, or about 3.3 fluid ounces. Centiliters are 100 times smaller than liters. If you were to compare centiliters to ounces, a centiliter would be equal to about 1/3 of a fluid ounce. Milliliters are 1,000 times smaller than liters. If you collected about 20 drops of water, you would have a milliliter. Microliters are 1,000,000 times smaller than liters. Microliters are very small. You can compare the volume of a microliter to roughly the size of a medium-sized salt crystal. Why do microliters matter? Because units this small are regularly used in scientific procedures. For example, liquid chromatography is a common laboratory technique used for the separation of mixtures. Injection volumes of as small as 5 microliters are sometimes used. Polymerase chain reaction, or PCR, is a technique used to identify nucleic acids. Because of the extreme sensitivity of this process, methods have been developed that use single microliter quantities of liquid materials. Nanoliters are even smaller than microliters at 1/1000th of a liter. Electrophoresis, a technique used in laboratories to separate molecules, often measures volume in terms of nanoliters. Let's return to liters for a moment as the basic unit of volume measurement. Scientists in the field often work with measurements that are larger than liters. So let's look at these larger units next. A dekaliter is 10 times larger than a liter, so a dekaliter is equal to about 10-liter bottles of water. Hectoliters are 100 times larger than liters. A hectoliter is equal to 100 bottles of water, or about 26 gallons. Kiloliters are 1,000 times larger than liters. A kiloliter is equal to about 3 bathtubs full of water. Megaliters are 1,000,000 times larger than liters. A megaliter holds about as much water as an Olympic-sized swimming pool. Gigaliters are 1,000,000,000 times larger than liters. The water volume of a lake, dam, or other large body of water is usually measured in gigaliters. For example, Lake Leak in Tasmania holds about 22 gigaliters of water, while Sydney Harbor holds about 500 gigaliters. While it makes sense to understand all these metric units of volume, the ones that are most commonly used in the sciences include microliter, milliliter, liter, and kiloliter.